Hello and welcome to section 5, where we begin to implement the RTS Entities plugin. So what is the RTS Entities plugin? The RTS Entities plugin is going to handle all the interaction of our RTS system with any type of entity. It will allow us to communicate to any generic entity, so a character, a vehicle, a plane, whatever we have in our game, without dealing with each of those entity-specific classes. So the type of communications it's going to handle for us is data spawning, selecting, commanding our moving our units around and their behaviors, just anything to do with characters and anything you can describe as an entity in the game. For the most part, it's going to be something that the player commands in the RTS. And why do we want something like that? It's so we do not have all these links to static classes. We can just plug in a character that we've got in a game, and it just works with the entire RTS framework. And when we come to our next project, or we need to include another character into the same project, we don't need to change anything. It'll just plug into the RTS framework, behave as an entity, and we can talk to it, we can use it, and do whatever we need to do. Now, as the framework gets more advanced, we're starting to get multiple plugins now, and we're going to begin to have multiple interactions between those plugins, and we have to be careful that we don't end up with all these dependencies. So the idea of the plugins is that you can drop one in without it needing anything else other than core. So we have to be careful that we don't generate, when we want to talk to another plugin, we have to be careful we don't create a dependency between that, because once we create a dependency, say for example between RTS player and RTS entities, every time we want to use RTS entities or RTS player, we need both, and we don't want that. We want to try and keep it as modular and separated as possible. So there's a few key programming concepts. It's nothing really crazy. You probably use it every day, and you may not realize that it's called, polymorphism, something like that. But so I'm just going to cover these topics really briefly, and then because I think they're important to understand. Otherwise, there's going to be a lot of confusion over why are we doing this? It seems overly complex, and the whole point of it is because it's to stop those interdependencies or just talk between plugins. So starting with inheritance, use inheritance probably every day if you're doing programming, but inheritance is just a derived class that inherits from a parent or a base. And this allows us to, have reusable code and reduces the code length and sort of gives structure to our classes, so we can organize particular code that's meant to perform some function into a class that's sort of compartmentalized then and easy to read, and that's the sort of structure I'm referring to there. So we'll be using inheritance between the plugins, so we'll be inheriting from our core classes into our other plugins, so that's where inheritance is going to come in. And then for example in RTS entities, we're going to want to inherit from some base classes, and then the child class that we inherit in RTS entities will then implement the entities part of the code that we need in that class. So polymorphism is where it generally applies to functions and methods, and it's the use of overloading and overriding. We use these to determine the functionality of those functions and methods. So a class can use the virtual keyword, which allows you to override the function, and then that function allows that class or subclass, whatever it is, to provide their own implementation of that function or method. Overloading is where you have the same function or method that just has multiple implementations. So you might want to pass in different variables to different overloads. So where we'll use overriding we'll probably have a base class which will implement some virtual function, and then when we inherit the class into another plugin, then we might override some of those functions for that plugin. So interfaces, which we've started using already, the interfaces really just enable polymorphism by defining a contract specifying a set of functions that the class must implement. So each class implementing the interface can specify its own implementation by essentially providing an override to that function or method. The interfaces provide several benefits, but our focus at the moment is just the benefit we get by that it allows us to decouple things. So we don't We don't reference a specific class, we reference interface, and therefore we don't have a link to that class in another plugin. That's how we're decoupling. So decoupling allows classes to interact while not creating a direct dependency. We can leverage this to prevent that interdependencies between our plugins. And we'll see this fairly early on, how we do this in RTS Entities, because we need to, the example that we're going to be doing probably straight up is we need to override, we need to inherit the player controller, and we want to implement in our player controller, we need to interface to our entities, the selection and command functions, and then we'll then need to talk to the entities, and that's where the interface comes in, and we'll have a contract to say, hey, you're going to be a character in this framework, you need to implement these functions. So I'm not going to go too much more into anything like that because it just gets too specific, but there's a general overview of the things that we're going to be using to try and stop having links between our plugins. So let's start on creating the RTS Entities plugin. So in the editor, we've done many times before, we're going to go straight to plugins, add a new plugin, blank, call it RTS Entities, whatever you want to call it. Now we've got our RTS Entities plugin. Let's start with inheriting that player controller from core. It's going to be called RTS Entities. I'm going to inherit from the player controller. I'm going to put it in framework player. So the reason why this is erroring is we don't have a link to player controller. I'm going to come to the build, and I'm going to put in the public dependencies. I'm going to add the RTSCore. Also in the U plugin, I'm going to cheat and copy some stuff. So I'm going to come into player U plugin, and I'm just going to copy this first part. So we just need to include the plugin RTSCore. Close that bracket off. All we need in there, all we need in there, and this may take a little while, but it'll come good. Let's create a constructor, open the core one, and copy some things. We can also make this one abstract. Oh, sorry, actually, I include the H file. That's why it's taking that long. So I think we'll go straight into implementing the input interface. If you recall, in core interfaces, we have this input interface, which has these commands that we wanted to outsource to something else, and then we're outsourcing it to, actually, I'll close this, don't get confused. But so this interface is what we need to implement in our player controller. Include that at the top. So now I'm just implementing those functions from the interface here. I'm going to implement the definition. We're going to replicate the properties in here, so I might just add that now. That'll be ready to go. It's going to error until we have a replicated view property tag in the H file, but that's fine. We'll have that soon. Actually, before we start setting up like selection and all that here, I might just come back to the core player controller, and in here I want to put in variable, and it's just going to be a position that the player starts in. So this will be used to spawn the entities at a particular location. We may use it for something else as well when as we progress, but initially we're going to need to know where the player's starting location is so we can spawn their units or their entities at that point. Otherwise, every player's entity is going to be at 000 or something like that. And we might just make now where this is going to come from is when basically when the game mode decides where that player is going to start. So we're going to come into the game mode and we're going to override player start implementation. We'll leave the super in there in case we don't find anything. I just want to check we've got the world. So now in here we need to choose a player start, and we want to have a player start that the player claims, and later on we'll want to check if it's a player start for our team and things like that. So we're going to create a player start class. Yeah, so we'll create that in the player folder in here. We'll call it RTSCore player start. We won't need this to tick. We won't need begin play. I'll leave it there. We're gonna use an object initializer, so I'll steal that from somewhere. And we're gonna do a getter for it. And we can take this tick, set the false, rid of the tick, that old constructor. Alright, now we want a function to make it virtual, and we want to return a bool whether it's occupied or not, or it's been claimed by someone else. So we're going to call it try claim, and we want to pass a controller. We need another function here, just to, sorry, this should be public. And then we need another one here, is claimed. Check if it is claimed. Like just a getter. Be a property. Void. Okay, and if you don't know what transient is, it means it's not a saved variable, that's all. It's only going to be assigned at runtime, sort of thing. Now in the try and claim, we want to check, sorry, if our occupying controller is valid. And then we just check if it's not already claimed. Then we can go ahead with claiming it. And then later we might implement some sort of like team ID check. Back to our game mode. Now we want to iterate over those actors. So we need to make sure when we get into the editor that we replace any player starts with our for player start. Now we can iterate over those. So we're going to use a const iterator, a const actor iterator, so we can locate all those player starts that are currently in the map. That's the player start we want, and it's going to include that class that we just created, the RTSCore player start. I'll just call that actor iterator, getting them from the world. To use the actor iterator, you need to include the engine utils.h. We can start checking out, so we want to check player and let's start. So let's get the class from the actor pointer. That's valid, and it can be claimed. And that's the player start we're going to use. So we need to get the location and update the player's starting location. So now I'm going to reference the core player controller. And I'm going to get the position. And we're going to use our setter to set the player controller. And we're going to return, for the choose player start, we're going to return that player start. And then if we all fail all that, well, then we'll just go to the super. So that's that. I'm going to close the game mode off. Now we're back to our core. We've just set the player start. We don't need to replicate that because it's only going to be used on the server. However, later on, if we do want to use the player start for something client-wise, like UI or something, then we may need to replicate. Right, so one thing I do want to do is in RTS player, there's a function we use to get the position on the terrain. The terrain position here. So what I want to do is I want to move this to our core player controller because there's going to be a few functions that are just sort of shared around and we might as well put them in a central place and not double up essentially. So I'm going to call this. So we could put them in a like a static class, but these are functions that are used to player controller, so we might as well put them here on our base class. And include the static game data, which has the channel there. And now on our player pawn, we just need to have a look where this is used. I think that's the only location. What we'll do here, we'll include our player controller 4, so it should link fine. Because it's a pawn, we should be able to get control. That could be constant saying there, so good. Untick. And now the back in here shouldn't be any uses of this. So it's not, we don't need that there anymore. This. Oops. Alright, so I'm going to close the pawn off now. And we'll come back to our core player control because there's another utility I want to add here. And it's going to be get mouse position on. I'm not sure why that's grayed out. I think it's because we haven't used it yet, but anyway, cracking on. So now we just need to do a trace from the mouse position on our terrain channel. We can probably copy it from this up here, to be honest. So this bit definitely, and then I need the result. And the start's going to be the world location, and will be world location in the direction. We don't need collision parameters for this. We want to do the blocking yet. And then terrain position will be the location. Yeah. Sure what's going on with this. There's definitely a function in. Apologies if you could see that error and watching on, but okay, so moving on. That's some utility functions there, I think. I'm going to leave that there. In the next video, we're going to start on entity selection. Thanks for watching.